In this video, we will study how to simulate the attack by a malicious node and subsequently apply the intrusion detection system as a security measure. Mobile ad hoc networks, MANETs, are vulnerable to different types of security threats that can degrade network performance. These attacks can include denial of service attacks, routing attacks, Sybil attacks, etc. An intrusion detection system is the solution to these problems. An IDS system analyzes the network by collecting data and studying nodes for abnormalities. To start, add a malicious node into the network using the file malicious.c available with NetSim's DSR library. The code flow is such that if the node is a malicious node, then when a root request is received, the function adds the root from itself to the target in the root cache and sends a false root reply, indicating that it has a route to the destination. This causes the source to choose a route to the destination via the malicious node. Create a network scenario by clicking on Simulation, New, Advanced Wireless Networks, MANET. Add 5 nodes as shown. We have taken an example where node 2 is malicious from time t is equal to 0 seconds. The goal of the IDS is to detect this malicious node and then set up a new route to the destination, avoiding the malicious node. Note that MANET environment operates as a wireless channel and hence path loss occurs. Right-click on the environment and click Properties. Select Channel Characteristics as line of sight and set the path loss exponent relatively high, for example 3.5, so that node 1 does not directly communicate to node 5 and routes via intermediate nodes. Also, viewers should note TCP involves receiving acknowledgements from the destination. Therefore, disable TCP for all nodes as shown. Set the traffic with source and destination ID as node 1 and node 5 respectively. Now coming back, the IDS system has been developed using the Watchdog and Path Rater algorithms. First, let's look at the Watchdog algorithm. In the wireless LAN project of NetSim, 2 files, watchdog.c and watchdog.h, have been added. The algorithm works such that once a packet is forwarded to the next hop node, the current node checks for watchdog timer duration if the packet is getting forwarded further on to the destination node or not. It is assumed that a malicious node does not forward the packet that it receives. A watchdog timer in the node which forwarded the packet counts down, and if the next node does not forward the packet, it expires. A counter is present which measures the number of times the watchdog timer expires. Once this counter's value reaches the failure threshold, the next hop is marked by the current node as a malicious node. The following functions are present in the file. The function watchdog init initializes the timer. The function add watchdog timer starts the watchdog timer the moment a packet is sent. In the function check-in sent list, the current node checks for a duration equal to watchdog timer if the packet is getting forwarded further on to the destination node or not. The function watchdog timer execute marks a node as malicious if the number of packets the node doesn't forward equals the failure threshold value. Next, coming to the path rater algorithm, this algorithm blacklists the malicious node by rating any path via that malicious node as obsolete in networks running DSR in layer 3. When the node is a malicious node and a root reply is processed, the function verifies the root reply in the root cache and checks for the blacklisted node, that is the malicious node. When there is a malicious node, that root entry is deleted from the cache. The following functions are used to perform these tasks. The function add to blacklist adds the IP address of the malicious node to the blacklist, indicating that it is an intruder. The function find IP in blacklist returns true if the device is blacklisted. The function verify root reply verifies the IP address obtained from the root reply and checks if it is blacklisted or not. It returns true if the root reply is not from a malicious node. The function blacklist found deletes root entries from the cache when the node is blacklisted. Users running NetSim v8.2 can open netsim.sln in Visual Studio and include the required files. Right-click on DSR in Solution Explorer and click and add the files pathrater.c and pathrater.h. Similarly, for WLAN, add the files watchdog.c and watchdog.h. Right-click DSR in the Solution Explorer and go to Properties. Under Configuration Properties, Linker, Advanced, edit the import library as shown to libdsr.lib. Build DSR followed by WLAN and copy the DLLs in the bin folder of NetSim as shown. Take care to rename the original libdsr.dll and libwlan.dll so as to preserve the original binaries of NetSim. Now we come back to the NetSim scenario and click on Run Simulation button, which opens a window where we enter the simulation time as 50 seconds, experiment name, and then enable record animation and leave seeds at their default values. After the simulation is complete, click on the View Packet animation on the left hand side. We see that node 1 sends DSR route request to which node 2 replies the fastest. Hence, node 1 forwards all the packets to node 2 to be forwarded to the destination. Node 2, being the malicious node, doesn't forward these packets to the destination node. Node 1 runs a watchdog timer of 2 seconds and finds that packets are not getting forwarded from node 2 within that duration. Once the count of packets reaches the failure threshold, the node is detected as malicious node and any route from that node is deleted from the route cache. After that, node 1 sends packets to node 3, which in turn forwards the packets to the destination node. Thus, the malicious node is detected by the intrusion detection system and packets now traverse in the route from node 1 to node 3 to node 4 to node 5. Hope you enjoyed this video.